Hello everyone. Today's topic is polymer orientation. In this lesson, we will briefly introduce the concept and mechanism of polymer orientation. The aggregated structures of polymers include the crystalline state, amorphous state, liquid crystalline state, and oriented state. These structures are formed during the molding process. The oriented state has a major influence on the properties of polymers and their products. So, what is orientation? When polymers are subjected to external stress, their molecular chains become aligned parallel to the direction of the stress. This phenomenon is called orientation. When the external force is removed, the oriented macromolecules will automatically return to a freely coiled state. This is called disorientation. The orientation process is a process in which orientation and disorientation reach a state of equilibrium. Although both orientation and crystallization involve ordered molecular arrangement, there are distinct differences between them. Orientation refers to one-dimensional or two-dimensional order, meaning that molecular chains are arranged orderly in one or two directions. Crystallization, on the other hand, is three-dimensional order. During the polymer orientation process, orientation and disorientation occur simultaneously. It is a thermodynamically unstable state. Crystallization, however, is a thermodynamically stable state. After polymer orientation, along the orientation direction, the intermolecular forces are mainly chemical bonds, while in the perpendicular direction, the intermolecular forces are mainly van der Waals forces. Therefore, after orientation, polymers exhibit anisotropy, whereas crystallization exhibits isotropy. The degree of polymer orientation is expressed by the orientation degree. In practical applications, it is often represented by the draw ratio. The draw ratio equals the length after stretching divided by the length before stretching. The larger the draw ratio, the higher the degree of orientation. However, this is not a simple linear relationship. Next, let's discuss the mechanism of polymer orientation. The orientation process of polymers is the ordering process of molecules under external force. Under external force, the moving unit is called the orientation unit. The orientation units of polymers include chain segment orientation, molecular chain orientation, and crystalline orientation. Chain segment orientation occurs through segmental motion caused by internal rotation around single bonds. This type of orientation can occur above the glass transition temperature. Molecular chain orientation requires the cooperative movement of chain segments. It can only occur in the viscous flow state. Crystalline orientation is achieved through the destruction and rearrangement of crystalline regions. It generally requires the application of external force. For amorphous polymers, both chain segment orientation and molecular chain orientation are possible. In the high elastic state, only chain segment orientation occurs, while molecular chain orientation does not. In the viscous flow state, both types may occur. However, chain segment orientation occurs first, followed by the orientation of the entire molecular chain. The orientation process of crystalline polymers is relatively complex. In addition to chain segment orientation and molecular chain orientation in the amorphous region, crystalline orientation may also occur. The external force in the orientation process means that orientation requires the application of external force. This can be a mechanical force, such as tensile force or compressive force. It can also be shear force from fluid flow, as in extrusion or spinning during processing. It can also be an electric field or magnetic field force. These external forces cause polymer chains and segments to align in specific directions. Disorientation process. Orientation refers to the ordered alignment of molecular chains along the direction of stress. Once the external force is removed, thermal motion between molecules drives the system back to a disordered state. This is the disorientation process. Orientation and disorientation occur simultaneously. The final degree of orientation depends on the balance between orientation and disorientation. To maintain the oriented structure, cooling, cross-linking, or other methods are usually applied to fix the orientation state. Time and temperature dependence of orientation. The motion of orientation units must overcome the viscous resistance between molecular chains. Therefore, orientation requires a certain amount of time. The degree, rate, and final structure of orientation strongly depend on the duration and temperature of the applied force. At high temperatures, molecular thermal motion intensifies, making orientation more difficult and less stable. At low temperatures, the oriented structure forms and remains more easily. Understanding and controlling the mechanism of polymer orientation is crucial to materials science and engineering, because it directly affects the mechanical properties of the final product, such as strength, toughness, elastic modulus, optical properties, and other functional characteristics. Let's briefly summarize today's lesson. Orientation is the phenomenon in which polymer molecular chains align orderly and parallel to the direction of external stress. The degree of orientation is expressed by the orientation degree. The orientation units in polymers include chain segment orientation, molecular chain orientation, and crystalline orientation. The forces causing orientation include tensile forces and shear forces during flow. During the orientation process, disorientation occurs simultaneously. The orientation process strongly depends on time and temperature. Thank you, everyone.